We are moving now to our next keynote speaker for the afternoon. And he is going to talk about how artificial intelligence is changing the game. Very interesting topic today from the Senior Managing Director at Accenture, Mr. Frank Riemensperger. Mr. Riemensperger, are you here? Oh, come on up. I didn't see you there sitting right in front of me. Let's give him a round of applause, everybody.
Hi, Jeff.
Hi, it's good to see you.
Good to see you. Hi everyone. I will talk about artificial intelligence, how is it changing the game, and actually how do we at Accenture apply it in business already with many of our customers. If you look at the technology, here's the timer. If you look at the technology, it's not a new technology. It's actually probably 70 years old. Started with Turing and the Turing test in the 40s, and it has developed very, very slow. And I will talk to that, why it has developed slow and what's happening now, and why do we suddenly see a breakthrough. There were a few first glimpses, like the big machine won the chess championships in the 80s or early 90s. We saw uses of artificial intelligence, the Tamagotchis and a few other things. But now we are at a real pivotal point. We are at the point where the technology will have a breakthrough. And why is it now? Because if you see other technologies like the Amazon online retailing, if you look at the IoT and other things, they were faster than artificial intelligence. Why is it only now? And that's very simple. If you look what artificial intelligence is all about, it's actually two things. It's really good deep learning algorithms, or it's three things. It's about a lot of computing power, and it's about a real lot of data. And actually the cloud is bringing that all together. If you see what's happening in the cloud and the cost of storage, you know all that Moore's law. If you see the exponential growth of data, I think actually that is a pivotal point which makes artificial intelligence or deep learning now happening today. And then you have the platforms in the cloud which start interacting with each other. And you have virtually with the big in the cloud data centers unlimited CPU. And this is actually all coming together now. And if you give you one example, if you look, how does a car learn how to stop at a stop sign? It's actually deep learning and artificial intelligence is about the practical things in life. It is very simple. You write an algorithm to instruct the car to stop, and then you need to train the algorithms. And how do you train the algorithm to do what it's supposed to do when you approach a stop sign, and after the sensor has detected there's a stop sign, you need to show the algorithms a lot of stop sign pictures. And how do you do that today? You go to the cloud and you find on the cloud, in all the different platforms, you find 100,000 or 200,000 stop sign pictures, and you start training the algorithms. Actually, that's how it works, and that's why the algorithms become so good. You didn't have access to that data only like 5 or 7 years ago. And this is actually now changing. The data, the quality of the data, the breadth of the data is making the difference. And that's why we see in the cloud a breakthrough of the intelligence. Now, what is artificial intelligence? It is not properly defined. I think human intelligence is actually not properly defined. But if you look what we typically see, you see technology which senses, like humans do. You see technologies which trying to comprehend, like humans do. You see technology which, after sensing and comprehending, is acting, and then you see the technology which is learning. So artificial intelligence is actually all about mimicking what humans would do in the same situation. Probably with much more muscle, because the tools artificial intelligence has at their hands are much more powerful. Now, typical applications we see, and this is all about the sensors now. We're talking a constellation of technologies which trying to imitate what humans can do. You see sensors which can taste. You can see sensors which can smell. We have a lot of sensors now which can see, which can hear, which can touch. All the things we can do. But then there are other sensors around which senses animals have, but humans don't have. You know, recognizing echo, recognizing UV radiation, recognizing magnetic fields. So basically all that is available. And if you look what's happening, it is an amazing amount of sensors coming to the world. Actually, this combination, this fusion of technology, and there's talk about having 50 billion sensors out in the next few years, that will enable actually the artificial intelligence because it's a source of the data. I'll give you one example. Bosch in the country here is one of the sensor producers. You know, and if you take your smartphone and you turn it, it's a small gyrometer, 15, 16, 17 function, fits under your small fingernail. You know, on a good day, Bosch is producing, of the best version of that sensors, they're producing 1 million of the sensors on one day. And they have a full sensor line. Just gives you a feel how much basically sensor data is going to be out there in the near future. And that is all data available actually to feed the deep learning algorithms. That's why we will see the breakthrough. Now, maybe you have seen Hiroshi Ishiguro on stage actually yesterday. You know, it's artificial intelligence is about mimicking humans. And Hiroshi was here yesterday. I had lunch with him. He talked about basically what he's doing. And his background that's very interesting. He says, I'm actually an oil painter by training. I'm not a computer scientist. He says, I'm an artist, and I started with oil painting. And he said, you know what does oil painting do? They try to mimic real life. And he said it got too boring for him. And he said, as an artist, I started to build robots. And he's probably one of the most famous artificial intelligence, actually, pioneers in Japan. He says, I started to build robots which mimic humans. And the first thing he said I did as an artist, I made them look human. And now he's experimenting, actually, how far can the technology go, mimicking human behaviors in robots which look like humans. And he said, you know, it is actually, if you start doing that, you recognize it's today still a very dumb machine. You know, you can have transactions, you can ask the robot, you know, how late it is, or what's happening in my schedule, and a few other things, but you can't have a deep conversation. But he says, you know what I'm doing now? I'm training the robot to inspire the imagination of the humans. And he says, you know, the most progressive use of artificial intelligence is, say, can I train a machine so I inspire the imagination when the human interacts with the machine, because the imagination of the people is unlimited. And he's prototyping that in elderly care. So he says, I founded 10 businesses. He's prototyping that in elderly care. He's prototyping that in fashion retail. He's prototyping that as basically guides on train stations. And he says, it's not about actually being always correct. It's about basically giving people ideas with data they didn't have before in a way you put them very intelligently together. So I think that is actually one way of where we see artificial intelligence in use, and the elderly care case is actually making its round, where he created robots for patient treatment. Analysis shows basically people spend 20 to 30 minutes with a robot interacting with them. So that's one use of application. If you go through, most of you interact with artificial intelligence today without recognizing. You know, if you pick out your smartphone and if you use Siri, well, that's what you have. If you drive your car, you know, and if your car keeps you on the road, there's artificial intelligence and deep learning in there. If you have your home cleaning robot at home, you know, how do you know all the floors cleaned? Artificial intelligence and deep learning in there. The drone direction, your cooking gear, unbelievable amounts of stuff, which is already out there, and you use it every day, but you don't recognize it. And that is the real power of artificial intelligence and the use it is invisible. It is invisible to the user, and actually the only thing you recognize, if it's done well, you have a better experience. So artificial intelligence is all about, as the next step, can I create better customer experiences in an invisible way? And we see three things, actually, which makes a difference here. It's intelligent automation, when we apply it to business. It's intelligent automation, so far it was all programmed automation. So can I automate in a way that I can respond to the unforeseen? It's basically labor and capital augmentation. It is machines which basically support you in what you do. And how's about that your machine recognizes you have a bad day? The machine greets you in the morning if you are in the shop floor, and you come by and the machine says, this was a bad night, Frank. I'll take it slow this morning. I get you up to speed without you making mistakes. That is what labor augmentation, and this is not a pun or a joke, this is really going on. So can the machine basically hyper-personalize to an individual user because he knows the user and he knows what the state he is in? We saw this morning or this afternoon a case presented by Tanya Rückert from SAP, where basically artificial intelligence is monitoring the bus driver and see, is the bus driver with school children in the back, is he driving in a responsible way? And that's exactly a machine watching you and making you better. And the people will love it because it's very invisible. And if you're paid on a bonus scheme based on productivity and making no errors, you will love it too. And you'll start accepting this technology. So labor and capital augmentation is the second thing, and the third thing is actually innovation diffusion. What does it mean? Innovation diffusion, things coming together, platforms, artificial intelligence, based on data from the IoT. So it's not one technology alone. It's actually basically the fusion of different technologies, which allows for new business cases. We have done an analysis and say, what could that mean to the GDP or the gross value add of the countries? And think about it as a huge uplift in productivity. Think about it that when people work more productively, they make less mistakes. When machines do things which people used to do, what could that mean to the impact on the GDP? Now, there's a dark side of it, and we'll talk about that later. There's a dark side about, will it cost jobs, yes or no? I give you the answer later. But if it's done properly, actually, that could be a real boost of the productivity of the economies. Unfortunately, it won't be equally distributed because only the economies, and that's why we analyzed some of these, only the economies which have a rock-steadfast digital infrastructure, which have smart products, which are all connected, will benefit from that technology. If that is not the case, and by the way, that's not the case in many parts of the world, the benefits will not be there. So as we say, the rich guy is going to be lucky again, and the countries which are behind actually will struggle to get the same benefits out there. And that's something to think through when we talk about universal basic income. Now, this is a big theory. Artificial intelligence is coming out of the box. The cloud is going to propel it. We're going to emulate human behavior on all dimensions you can imagine, and we're going to get better at it because we have not only the algorithms, we have the data to make it happen. So what's happening in business? And what do our clients do? And we work for all the large companies here in the region. We work for all the large companies around the world. And we see very specific uses already. Think about risk management. Text analytics plays a role there. So the blue boxes are not one-to-one related to the boxes above, but when it comes to risk management, analyzing and identifying risk, you typically crawl through millions of an insurance protocols, what happened, then you try to understand how you can improve. Omni-channel customers, it's a huge case. If you are online on whatever channel, LinkedIn, WhatsApp, Facebook, whatever, are you talking to a real person or are you talking to a chatbot? You don't know actually anymore. Use case robotics. You know, the self-programming robotics is a big use case. You know, they cost now less than 10,000 euros, the more affordable one. So you can buy a robot and you can train him by moving his arm manually on what to do. And that is a big use case in the small and medium manufacturing environment. The intelligent operations, so basically recognizing predictive maintenance scenarios, not only by monitoring, but by using the data and deep learning algorithms to do the prediction better. And then you have cybersecurity and many other things. Video analytics is another case. You know, if you look at London, there is one camera for 4 people living in London. No way anybody can look at these video streams. It's all about deep learning algorithms to really understand what's happening. And then, you know, the next level is what's going to happen. So what London is working on is intention-based video analytics. Is somebody walking through the tube, which will basically throw a bomb? That is the next level of deep learning which is going on. So unlimited uses of applications. And we are using now with our customers, step by step, the algorithms to really start improving the business processes incrementally. This is not disruptive now. It may become disruptive over time. But at the moment, many of these things are really incremental improvements, but they make a difference. Think about, and I talked about them, think about the digital assistants. Think about the chatbots. They are the new apps. You know, the chatbots are actually very easy ways you as a provider of services on the internet can have a meaningful conversation with your customers without having people in the center. And the way it works today is actually that a conversation on the internet starts with a chatbot, and after a while, if you know the complexity goes beyond, you're transferred to a real agent. And maybe you don't even recognize. You recognize you're a different person you talk to, but maybe you don't even recognize that you talk to a machine at the beginning. And the simple inquiries are all automated, and then basically you integrate that. And what our clients do, they integrate that into their backend systems. And we have retailers doing that. We have insurance companies doing that. We have supply chain spare parts replenishment companies doing that. Unlimited use cases for the chatbots. That is becoming commodity now. And there's a myriad of software providers out there. IPsoft is just to name one, and there are very, very many, which basically provide these chatbots with deep learning out of the box. You don't need to hire 20 data scientists or hire 20 artificial intelligence people. You get these, that's the state of the industries. You get this stuff now out of the box, and you get going with the APIs provided on the cloud within a few days. And that makes a difference. Usability and the cost has come down in a significant way. Now, this is a second application which we have programmed in Singapore. Take a look.
This asset is specifically built for a casino scenario. What it does is reads information from the surveillance videos that are mounted on top of the casino floors. And this could be across tables, be it a blackjack table or a roulette or a poker table. Traditionally, what happens in casino floor is right next to a table there is a supervisor who keeps monitoring the table in terms of shift and rounds. So what the solution does is kind of remove the human intervention there, also reduce the error rate in terms of how a human would react to picking anomalies versus how a machine is doing it. What runs behind the asset is a combination of computer vision techniques as well as deep learning methodologies that run behind and reading the information and predicting whether a particular betting scenario is happening on the table or not, and pick out anomalies and also specific events of interest that the client is looking for. So the first impact is directly on the revenue part, where the casino people now have a clear view of what table is more profitable at what time of the day and what is the dealer shift that is causing that. The second impact is on the operational perspective, where the supervisors are standing right next to the casino tables right now doing the monitoring part, and that the human errors and accuracy, that part is eradicated as well, in, where the machine is overtaking.
I think you get the idea of what's going on here. The biggest problem for casinos is fraud at the table. You know, and if you try to prevent that fraud, with supervisors next to the table, you have to be damn good. With this application, this is all real time, you start combining a lot of things humans can do, and you get to a level of perfections which humans cannot match anymore. And this is real money, this is real income loss prevention for the casinos, because you can figure out what's going on, and that gets now to a level of perfection which is actually unmatched. And you can take this example from the casino and apply it to any other surveillance task you can think about. Artificial intelligence empowering smart services. This is not only about the casino situation or the chatbot and the internet. We see actually artificial intelligence coming mainstream in industry. If you think about Siemens, they do the best radiology machines in the world, competing with GE, next to competing with Philips, but they're clearly at the top league. And this is a machine which costs $1 million, and this machine is basically doing pictures. And if you not only try to improve the picture quality, but if you try to improve actually to understand what's on the picture, you start to change the competition. Siemens is doing that with the picture. Bosch is doing that with the robotic platforms you use in agriculture. How you do precision farming. ThyssenKrupp is doing that actually with running elevators. And that is a real competitive advantage if you can improve the throughput in the elevators, which is basically the infrastructure of the city. Everybody waits in a large city in front of elevators. So you can improve the throughput, and that's a competitive advantage. Or KUKA is a self-controlled robot. So we see artificial intelligence actually becoming mainstream in many of the products which are manufacturing in this part of the world and obviously in the other part of the world. So that is happening today as well. Now, many of these things are incremental. When does artificial intelligence become disruptive? And that is something we have to watch out for, especially in Germany, because when we think about digital, we always look at the robots on the right and say, how can we make the robots more productive and work faster? And AI actually helps to do that. But when the Silicon Valley looks at artificial intelligence, they always look at the human, they always look at the people first and say, how can we give these people a better experience? And if you look at all the winning platforms in the world, they are not about better IT systems. All the winning platforms in the world actually scaled because they were able to give the user a completely new experience which changed the competition. So, and that is a framework we have developed actually with the Akatech. The Akatech is the Academy of German Engineering and Sciences. And we have developed a framework really to look into the future of the German industries, which is all about smart products, and say, what happens if we apply if you connect the products to the internet, apply platform analytics, and that gets us into the incremental side of the house, it becomes more disruptive if we are able to define platforms and create ecosystems. And the game is going to be about how many other people can I get to contribute data to the way my own products are being used and operated. And the more data you get, the larger your ecosystem is, the more you will be able to configure smart services around your smart products, and that will shift the competition. And once you have enough data, then you will be able to really hyper-personalize to the one individual user of your machine. And I just mentioned it, a scenario where a machine recognizes its operator, recognizes the state of the operator, and makes out of an average or even low-trained operator, not a non-trained, that won't work. But an average or low-trained operator, can turn into a high-performance operator, working probably in the top quartile within a matter of days, not within a matter of years. And that is the difference of artificial intelligence, and that's why it's important. So we can give actually the user a new experience that he can do things much better or perform much better before, and it's done in an almost invisible way. And if you think through what that means, that will lead to that our machines, as we know them today, will be engineered and manufactured in a completely different way. That is the future of the German industry. And we say artificial intelligence is a new user interface. Actually, if you define yourself as a car manufacturer, and the user interface is the steering wheel and the dashboard, if you go to autonomous driving, actually the quality of the artificial intelligence and the way you interact with the car, because you won't have a touchpad anymore, you won't use keyboards to interact with the car, you will talk to that thing. And if the thing reacts to that beast driving you, if that thing reacts very well, you love it, you like it. And that is a new user interface. It's actually these deep learning algorithms, which will be the user interface to the product, and the old things you know today will be gone. The touchpads will be gone, the steering wheel will be gone, the dashboards will be gone, and any other form of interaction will be gone as well. So AI is no longer about how you do the things, it's actually who you are. It will redefine the brands. That's where the disruption will come from. And if you have the opportunity to listen to Johann Jungwirth yesterday, he's a CDO of Volkswagen. I listened to his presentation yesterday. That's exactly what he's painted as a vision for Volkswagen. He says, actually the quality of the product experience in a car which looks like that car, which is a self-driven car, is not anymore in the way actually you interact yourself with that device. It is actually the quality on how that device will serve you without a lot of talking or other interactions. And that quality will be the differentiator in the future. Quite different product to what we know today. So artificial intelligence will become the new user interface. The way actually your devices interact with the humans, augment the humans, will be the thing you compete on. And that is quite new, and that will all happen in the next 5, 6, 7 years. And that means actually AI will as well transform the way we work. If you're a bus driver or if you're a car driver today, you start looking for other things. And we see a lot of examples actually where the mimicking of human capabilities suddenly lead to ways how work is, the way to rethink how work is done. This is a very simple example from tree counting. And, and it's very obvious if in the big plantations in the southern part of the world, there are tree counters out there which checks the status of the plants. And typically it's a team of 4 or 5 people going out for a month to inspect an area of a few square miles. You can do that today with drones and with the right algorithms in a question of hours. That is, and then you basically, with the algorithms, you identify real time on the spot where intervention is needed. And obviously, that sets capacity free for these people to do other stuff. And this is the example here, what used to take 36 hours, we have now in 6 minutes. What used to take 4 days for a team of 2, it's now done in a few minutes. We will find with AI and the ability to process data in a significant way, you'll find many use cases. And that will lead to a discussion actually, progressively over time, on how do we organize work. How is work organized? What work is performed? Who performs the work? Why and when where people work and how work is led and managed will actually change under the influence of artificial intelligence. And for us it means, and we are a people business, we are basically in Accenture people, which we train people to work to excellence. I know already today that with the new artificial intelligence-based ecosystems on the platforms, I can refocus my people to do more qualified tasks, being augmented by artificial intelligence, but they will do that in a very different way. And the one thing I'm probably going to reduce is office capacity, because these people will be out on the site where intervention is needed, but they won't come to the office anymore. Many of these things will be automated away. So we have 390,000 people, and with the use of artificial intelligence, actually, we are seeing effects of 10% already. So we get in our service delivery centers, and from the 390,000 people, we have 250,000 people working in service delivery centers. We get today already application development, application management, finance, accounting, HR, personnel tasks. We get through the use of artificial intelligence, 10% productivity improvement. That's a lot on 250,000 people. And we set them free to do more work for more clients today. Now, AI will transform your business. Start with having the right people to do that. I'm pressing for time. We have a few very important alliance partners which we're working with and helping us. We have Google Launchpad as a collaboration. We're working with the MIT. We're working with the German Institute, with the DFKI. And we're really thinking through, actually, not on the big revolution. We're thinking through what we can do tomorrow to save 5 to 10%. And we do that a few years in a row. Actually, it's significant. We have to change the way we work. We are applying design thinking, industrial design thinking, to really shut down the cycle times. Stuff which is done in months has to be done now in days and weeks. And that's why you need a new methodology set. If you want to learn more about that, join us next week, Friday. We have a full day around artificial intelligence in Munich. It's a precursor of the German Innovation Prize. And we'll have Jens sitting on stage giving a keynote for Google. We have a lot of experts really take you through the German industry, what's going on already actually in the lead companies of the country. Thanks a lot.
Yeah, I'm going to go. Yeah,
so I pass back to...
Yeah, we've got time for one question. And I was going to ask you, you said that artificial intelligence is who you are. That's quite a statement, isn't it?
Absolutely. It will redefine the brands. You know, if you take autonomous car, because we all drive cars, you know, it's not about how you sit in your driver's seat and how you interact with the car.
Yeah.
It's actually about the car recognizing who you are, what state you are in, what are your desires, and it can respond to it. Mm-hmm. And actually, all that will frame your experience in interacting with that device. That frames your brand.
You also mentioned, too, that there are different ways that people approach AI. Do you think because we're here in Germany, do you think Germans are more skeptical of artificial intelligence than other people?
I don't think so. Germans are more skeptical on everything. Let's start there as a baseline. You know, have you heard Abe Shinzo on stage on Sunday in the opening? He said, you know, Japan is not afraid of AI. We're going to use it. Actually, I think AI is a technology people will like because it's very invisible. I repeat myself.
Yeah.
And if it's done well, it gives you a better experience. And now we all use smartphones. We all use artificial intelligence in smartphones. And we like it because it gives us a service. If we can transfer that experience to all the complicated machineries we are building, you know, we probably have a better experience, and that could be good. And how do you do that today? You go to the cloud, and you find on the cloud, in all the different platforms, you find 100,000 or 200,000 stop sign pictures, and you start training the algorithms. Actually, that's how it works, and that's why the algorithms become so good. You didn't have access to that data only like 5 or 7 years ago. And this is actually now changing. The data, the quality of the data, the breadth of the data is making the difference. And that's why we see in the cloud a breakthrough of the intelligence. Now, what is artificial intelligence? It is not properly defined. I think human intelligence is actually not properly defined. But if you look what we typically see, you see technology which senses, like humans do. You see technologies which trying to comprehend, like humans do. You see technology which, after sensing and comprehending, is acting, and then you see the technology which is learning. So artificial intelligence is actually all, and I will talk to that, why it has developed slow, and what's happening now, and why do we suddenly see a breakthrough. There were a few first glimpses, like the Big Machine won the chess championships in the 80s or early 90s. We saw uses of artificial intelligence, the Tamagotchis and a few other things. But now we are at a real pivotal point. We are at the point where the technology will have a breakthrough. And why is it now? Because if you see other technologies like the Amazon online retailing, if you look at the IoT and other things, they were faster than artificial intelligence. Why is it only now? And that's very simple. If you look what artificial intelligence is all about, it's actually two things. It's really good deep learning algorithms, or it's three things. It's about a lot of computing power, and it's about a real lot of data. And actually about mimicking what humans would do in the same situation. Probably with much more muscle, because the tools artificial intelligence has at their hands are much more powerful. Now, typical applications we see, and this is all about the sensors now. We're talking a constellation of technologies which trying to imitate what humans can do. You see sensors which can taste. You can see sensors which can smell. We have a lot of sensors now which can see, which can hear, which can touch. All the things we can do. But then there are other sensors around which senses animals have, but humans don't have. Recognizing echo, recognizing UV radiation, recognizing magnetic fields. So basically all that is available. And if you look what's happening, it is an amazing amount of sensors coming to the world. Actually, this combination, this fusion of technology.
We are moving now to our next keynote speaker for the afternoon. And he is going to talk about how artificial intelligence is changing the game. Very interesting topic today from the Senior Managing Director at Accenture, Mr. Frank Riemensperger. Mr. Riemensperger, are you here? Oh, come on up. I didn't see you there sitting right in front of me. Let's give him a round of applause, everybody.
Hi, Jeff.
Hi, it's good to see you.
Good to see you. Hi, everyone. I will talk about artificial intelligence, how is it changing the game, and actually how do we at Accenture apply it in business already with many of our customers. If you look at the technology, here's the timer. If you look at the technology, it's not a new technology. It's actually probably 70 years old. Started with Turing and the Turing test in the 40s. And it has developed very, very slow. The cloud is bringing that all together. If you see what's happening in the cloud and the cost of storage, you know all that Moore's law. If you see the exponential growth of data, I think actually that is a pivotal point which makes artificial intelligence or deep learning now happening today. And then you have the platforms in the cloud which start interacting with each other. And you have virtually, with the big in-the-cloud data centers, unlimited CPU. And this is actually all coming together now. And if you give you one example, if you look, how does a car learn how to stop at a stop sign? It's actually deep learning and artificial intelligence is about the practical things in life. It is very simple. You write an algorithm to instruct the car to stop. And then you need to train the algorithms. And how do you train the algorithm to do what it's supposed to do when you approach a stop sign and after the sensor has detected there's a stop sign? You need to show the algorithms a lot of stop sign pictures.